Right, for this question we've got some vectors. You can see we've got O, A, C, D. It's a trapezium and it's made from three equilateral triangles. Now that gives me a little bit of help because if I know they're equilateral triangles, I know those sides are all the same and all the parallel, so I can just fill in a few little bits and bobs. I can put that that is A, I can say that that is B, I can say that's also B. Now it asks me to write AB in terms of A and B. Well, I'm just going to show you the route that I would take if I was doing to B. So I'm going, I can't have anything going directly down the line, so I've got to go here and across. So AB in terms of A and B is just simply negative A add B. Right, next one, we need to show that OC is parallel to BM. Now I'm going to do this in two different routes. First thing I'm going to do is I'm going to put here and do O to C. So O to C is equal to O to A, add A to C. O to A is A, and A to C is B. So I've got that sorted. I'm doing B to M. So, first thing I know is if I'm doing B to M, I need to know what C to D is because I want to know just half of this bit here. So I'm going to work out C to M. C to M is equal to a half C to D. Well, I know C to D, I just go from C to B and then B to D. So it's a half of, and you'll even notice that it's parallel to the one that I've worked out at AB. So it's negative A at B, so that's C to M. Now for B to M, I'm going to go B to C, and I'm going to go C to M. B to C, well that's easy enough, I've got A there. The next bit, I've got C to M. Well, I know that that's a half C to D, so it's negative a half A, add a half B. Simplify that, so I get negative, a half A, add a half B. Well, I can see that if I take B to M, I can factorise it, or if I take O to C even, I can take O to C like that. If I multiply O to C by a half, I get B to M because a half A add B is equal to a half A add a half B, therefore they are parallel. So that's that one done. Number 19 is some algebraic proof. It says prove algebraically, so I can't just use numbers. I'm going to have to use algebra. Sum of the squares of two consecutive integers. So I'm going to start with two consecutive integers, and I'm going to start with my first one is n. The next number after that, to find the next number, I just add 1, so n plus 1. And it's the squares of these numbers, so that's easy enough. It's squared, and it's the sum of them there. So what I do now is just multiply out my brackets for my first one. N squared plus n squared plus 2n plus 1. Simplify that up. 2 lots of n squared, add 2n plus 1. And I want to prove that that is always an odd number. Well, if I do odd, put it in red over here, odd, well, if I know what an even is, I always know an even is 2n, because if it's multiplied by 2, it's got to be even. And then to work out odd, I just add 1 to that. So then I need to factorise this out to look like that. Well, if I take this first part here, I take a factor of 2 out. I've got n squared add n add 1. So I've got 2 times something add 1. So it's 2 times a number, then